image object level hierarchies. Interesting. You might also find an acronym for this IOL, which stands for image object level. And as you might know, we can have multiple image object levels in a project in eCognition. And if you have multiple levels, we are talking about image object level hierarchies. And first I'm going to talk a bit about theory, and then we're going to have a lot of hands-on and a lot of examples on how to use an image object level hierarchy to classify image objects and how those objects can talk to each other. But first of all, a bit of theory. So what you see here is an example of an image object level hierarchy. At the bottom, you see the pixel level that is actually taken from our documentation. Then a fine scale segmentation and classification of trees. Then a medium scale image object level where tree types are detected. Then a coarse segmentation level where we have forest, and then the entire image. And if you set up a image object level hierarchy like this, you can actually use this hierarchy to your advantage because those image objects are connected even though they are on different levels. And it's important to distinguish between image object levels and image layers. Those are two different things. Like image layers represent the data that already exists in the image when it's imported, and the image object levels, they store image objects which are representative of this input data, right? Let's again have a look at a figure on the right hand side. So again, we do have multiple image object levels, and the tree type level is a super level of the tree level, and the forest is the super level of the tree type and also the tree. Whereas the tree level is a sub level of tree type and also sub level of forest. And as you know, all image objects know or are aware of their context. So within one image object level, an image object knows its neighbors, but it also knows its super level objects and also the sub level objects. So there's a connection not only within one level, but also across multiple hierarchies, right? Multiple levels. And very important is to understand that one image object can only have one super level image object and not multiple. But one image object can have multiple sub-level image objects, right? So the outlines of a super object are always gonna be present in sub-levels, right? You cannot destroy the outline of a super object on a sub-level. And that's important to know and to understand, because if you try to do a merge on a sub-level, it doesn't work. The reason for this is the hierarchy and that restriction that an object can only have one super object but multiple sub-objects. And now enough talking, let's have a look at the project. So we're gonna have a look at mapping impervious surface, and we're gonna use multiple image object levels to do so. So what we want to do is calculating percentage of impervious surface per parcel. And as input data, we're gonna have a vector layer, which represents the parcels, so polygons, and an RGB image. And actually, we're gonna use multiple image object levels. So we're gonna introduce an image object level hierarchy. We're gonna have a super level where we do the segmentation based on the vector. So one level that represents our parcels, and then we're gonna have a sub level where we actually gonna do the classification of the impervious surface. So we're gonna have a sub level with smaller image objects. We do another segmentation on that level, and we're gonna classify impervious surface on that sub level. And in the next step, we're gonna classify the parcel level, the parcels, based on the information of the sub level. And this actually can be applied on different projects or domains as you like. For example, forestry. If you have forest districts, you can compute the percentage of tree cover per district, for example. You also can create heat maps, or it's more or less, it's a heat map, right? What we're gonna compute, but you could do on a super level, a chessboard segmentation, then compute per object the percentage of tree gain, of water surfaces, of whatever. So a lot of different approaches here, and it is very nice to understand how hierarchies work in eCognition. So this is going to be, even though you're not interested in impervious surface, it's going to be very helpful for you. So please stay in this session. It's going to help you 100% guaranteed. All right, so here is the agenda. So first of all, we're going to create a project and load the data. Again, it's a vector file that we have and an RGB image. Then we're going to identify the parcel. So what we're going to do is we're going to create an image object level based on the vector input. So we have image objects representing our parcels, and then we're going to classify the parcels that we are interested in analyzing. Right, so we're going to have one level with our parcels classified. Then we're going to create a sublevel where we identify the impervious surface, and we're actually going to do a smaller segmentation on that level, and then we're going to classify impervious surface areas within the boundaries of the parcels that we are interested in. And then we're going to categorize the parcels based on the impervious surface information of the sublevel. So we're going to compute a percentage of impervious surface for each parcel on the super level based on the sublevel classification, and we're going to assign classes to the super level parcels, and finally we're going to export our results. So that's going to be the workflow that we're going to implement in eCognition. Okay, let's get started. So first of all, we're going to open eCognition Developer. I'm going to close this window here, and I'm going to use drag and drop to create a project. Let's open the data folder, and first of all, in the image data subfolder, I'm gonna open, let's use this 180.tiff. So we have a few tiles, but let's start with this one. Simply drag and drop it, and I also gonna go into this thematic data folder, and I'm gonna drag and drop the parcels.shp. Again, those are the two files that we're gonna use for this project. Let's see if that worked. All right, here's the image. I'm gonna change the stretch to standard deviation maybe, or linear. That looks good, and increase the factor here to 3. So that's the image data, again with 3 bands, layer 1, layer 2, and layer 3. I instantly gonna rename those red, green, and blue, so I'm not lost when I'm looking for these layers. Red, green, blue, and here's the thematic layer. Let's display this one, increase the outline width, and maybe change the color. So here you see the parcels of the shapefile, and actually shapefile is larger, it covers all the tiles, but in this case it's cropped to the extent of this scene. And now I'm also going to rename the thematic layer to Parcels. If this is done, I'm gonna click the Save Project button, and because I'm using currently the default workspace, I haven't created a workspace yet, and all projects need to be within a workspace, it's gonna ask me to first save or create a workspace, and within that workspace I can save that project. So click yes, and first save the workspace. I'm gonna choose the directory of the data, and within the data folder I'm gonna create a workspace called Parcels, and then this workspace. Hit OK, and now the project is saved in that directory, in the workspace directory, right? There is a folder, a DPR folder in the workspace directory, and within that DPR folder we gonna have a file, a project file with this name. So that is the default name given by the input file. You can change it if you like, if you go to File, Modify Open Project, but let's leave it like that. All right, so project created, data loaded. Let's switch to the rule set development layout, because now we want to create our rule set and define our workflow here in the process tree. And first of all, what we're going to do is we're going to create image objects representing our vector outline. So we're going to have image objects that follow the outline here of our vector. And in the next step, we're gonna classify certain parcels with a certain attribute which we want to analyze. So what we're gonna do is we're gonna create a rule set here in the process tree, and we're gonna give our rule set a nice structure right away. So using parent processes and child processes and so-called structural processes without an algorithm. And first we're gonna create a structural process. It sounds difficult, it's very easy actually. If you right click in the process tree, add new process, and yeah, if you want to create a structural process, so more or less a folder structure, you simply type in a different name up here, or you simply can leave it like that. If you click OK, you're going to have a structural process without an algorithm, but actually I want to give it a name so I better understand at the end my rule set, and it has a nice structure and it's easy to read and understand. So what we're gonna do is mapping impervious surface. So that's more or less the title of my rule set. So that's what we plan to do. Mapping impervious surface, and I'm gonna right click onto that process, insert child process. And first section is we gonna identify parcels. And in this section here, I'm gonna start using algorithms. So first we're gonna use vector-based segmentation. And the vector-based segmentation, let's look for it, vector-based segmentation. This one cuts out more or less your polygons, your lines, your points, and creates image objects based on the information of the thematic layer. So what we're gonna change is we have to define the thematic layer. So we just have one, the parcels, define it here. And the level name, we're gonna give it a different name. Yeah, parcel level. Right, so that's gonna be our super level in the end. Parcel level is going to be on top, and on a sub level we're going to have the analysis level. Simply execute this, and then we should have a image object level popping up here in the view settings. On top, right, I'm gonna undisplay the vector layers, and now you see the blue outline here. So we do have image objects now following the outlines of our vectors. That's a very easy and straightforward way to get image objects based on the outline of your vectors. You can change the outline color. No, black doesn't make sense. Yellow, right? And the selected object is displayed in red. That's the first step. Now we actually only want to analyze two parcel types. And those attributes are single family and mobile homes in the column LU_GRP in the attribute table of our parcels vector. So we're going to use information of the attribute table of our vector to classify image objects. Let's first have a look at the attribute table. So I display again our parcels vector, right click here in the gray area up here, choose thematic layer attribute table, and that will display the attribute table. In your case, it might be squeezed in between process tree and process properties. So you simply can drag out this window. And if you right click here on a column, you can choose enlarge columns, and then you're going to see what I see here. So that's the attribute table, and we're going to have a look at this LU_GRP. And we only want to use parcels that have this attribute, single family or mobile homes. And yeah, we have different attributes here, heavy industry, government, agricultural, and so on. But we're only interested in those two. So how do we tell eCognition to classify those objects based on an attribute in the attribute table? Good question. I'm going to show you that now. So what we're going to use is assign class. That's an algorithm that classifies image objects based on a certain condition. I'm gonna add a new process here in the process tree, and I'm gonna look for the assign class algorithm. And now the condition field is critical. Here we define which objects this assign class algorithm should classify. And we are interested in those that have this attribute in the attribute table. So where we have to go is here under Object Features, Thematic Layer, and double click this Create New Thematic Object Attribute feature. And actually here we define the thematic layer. In our case, we just have one, the parcels, and then the column. And we know that we are looking for this LU_GRP. Hit OK. And if you double click this one, it's going to be here as value 1. So if this is operator equals, so if this entry equals, for example, this mobile homes, all capital letters, I think that's crucial. I don't know, and I won't test it now, but that's probably the source of error. So if it doesn't work for you, check if the string equals the attribute name, right? So mobile homes, okay. And if this is true, so if it has this attribute, put it into the class Parcels. I'm simply going to type it in here, click somewhere, and then I can define the color, blue, and I'm going to execute it now. So it's looking into the attribute table, and if the entry in this column is mobile homes, going to classify it into that class. And we are classifying image objects, so not the vector. Okay, so that looks good. And the other one was family, no, single family. So I simply copy and paste this process because I'm lazy, and I'm only changing here the string to single family. Hit OK, execute, and yeah, there we go. So all parcels are now classified that have either the attribute mobile homes or single family, and we classify the image objects that we have created using the vector-based segmentation based on the input vector. Okay, so now we have one image object level that is called parcel level, and we've classified all the parcels that we're interested in. Now the next step is to create a sub-level where we do the analysis, so where we are classifying the impervious surface areas. And yeah, first of all, we need to create a second level, and we're gonna use actually one algorithm, the multi-resolution segmentation, and you can actually in the parameters define if the segmentation should take place on the current level or it should create a different level. So let's have a look at this. I'm also going to create a structural process so we have a nice and understandable structure and rule set. So I'm adding a new process and call it segment and create sub level. And I'm gonna right click here and choose insert child process, and that's gonna insert a child into that structure. And I'm gonna look for the multi-resolution segmentation. Yeah, here we go. And now important is that you change the domain to image object level. And actually now you can choose here in the parameters level usage, use current or create below. That's what we're gonna do. And we're gonna give that new level a name, analysis level. And yeah, class filter. Actually, you can limit the segmentation on certain objects, and we are only interested in our parcels, so we only want to do a finer segmentation for those objects that are classified as parcels. And yeah, the scale parameter, we're gonna set this to 15, and that's all you're gonna need to change. And that's gonna create a second level, and you're gonna see that one popping up in the view settings underneath the parcel level because it's lower in the hierarchy compared to the parcel level, right? We're gonna create it below. And again, it only will create image objects in our blue objects in the parcel objects that we've classified. This will actually take a few seconds because we are doing a segmentation within an image object level, right? And that takes longer than creating image objects from a pixel domain. Let's have a look at the analysis level. You see it popping up here as image object level. I can display it, and let's change the outline color now to yellow. And if we zoom in, we see both levels at the same time. The parcel level is the parcel outline here in black, and the blue fill, and the analysis level is below that. And we see the we see the analysis level because we have an opacity on the super level. If we set this to 100%, you don't see the below analysis level and the segments, but if we reduce that, you see it. You also simply can uncheck the parcel level and you only see the analysis level. And again, we only created now image objects, smaller image objects within the parcels that we've classified on the parcel level. Because we have constrained this in the multi-resolution segmentation, in domain settings, we set the class filter to the parcel class, and we've created a second level. And now the next step is actually to classify image objects here, our small new image objects, into a class Impervious surface. So let's have a look at this parcel here. So the building and the driveway, they should be classified into the class Impervious. And after we've done that, we're gonna continue and try to connect both levels and see how that works. So first step is to somehow classify here into Impervious and non-Impervious on the analysis level. Okay, let's go ahead and extract Impervious surface on our analysis level. And that's going to be pretty straightforward. We're going to use a simple threshold classification. We're not creating a sophisticated rule set here to extract Impervious surface. You can go ahead and improve this approach. It's just a simple one line that we're going to use to classify something which is not 100% correct, but also not 100% wrong. So again, I'm going to create a structural process here in the rule set, and I'm going to call it extract Impervious surface. And I'm going to insert a child process, and I'm going to keep it simple. I'm going to use a sign class, and actually we're going to use two conditions now. First, make sure that we are working on the analysis level. That's important. And what I want to do is I want to limit the algorithm on those objects that are our parcels, right? But that information is actually not existing on the analysis level. When we did the multi-resolution segmentation, we created a new level and new image objects, but the classification actually on the analysis level is lost. So we don't have classified image objects on the analysis level, but we do have those on the parcel level. And what I want to do now is I want to tell eCognition only classify image objects on the analysis level if on the super level the object is classified as a parcel. And yeah, that's what we're going to define here as value 1. If you have a look at the features, and we're going to go to object features, relations to objects, and relations to super objects, and we do have quite a bit existing. Where is it? Ah, here. Existence of, create new existence of, and now I can define here if parcels exist in a distance of 1, which means 1 level above. You can have 10 levels, and then you would need to set the right number here. But in our case, distance is 1, that means 1 level above. And if this is 1, so if this is true, I only want to classify those objects, right? If it's not true, it won't classify. And now in this condition, we actually can add multiple conditions. I'm going to simply click add new, and to classify Impervious surface, we simply going to use a threshold of mean blue. That's something I checked before, and yeah, it gives fairly good results. So under object features, image layer mean, if you go to blue, this has to be greater equal to 75, I think. Yes. Okay, so now both conditions have to be fulfilled because the type here, the connector, is AND. If it's OR, it won't work. But yeah, so we are restricting this process to existence of super object parcel has to be true, and if the mean blue is greater or equal to 75, then put it into the class unclassified in this case. But we're gonna create a class Impervious. Okay, and we're gonna give it also a bluish color. Okay, let's see what happens. Okay, so you see we do have classified objects now, and that looks pretty good. So all the buildings, see, you can play around and come up with a better threshold approach. Actually, this roof hasn't been classified, but for the purpose of this exercise, I won't go into detail here, and I'm actually happy with the accuracy. You might ask yourself, how did I find this threshold? If you don't know, we have two different tools that you can use to manually come up with a threshold. First one is here, the image object information window. So what you could do is actually click onto an object and you're gonna get the information of the selected object here, and you actually can select several features. In this case we have 3 features, but we also could display, for example, the mean, blue, green and red. And now you have the values for these objects. And what I usually do is I click on the objects that I want to detect or extract, and try to find a certain threshold of those values or a distinct feature compared to other objects that I don't want to classify. And yeah, you also see the super object feature here, Parcels. So this one has a super object in distance of 1, which is Parcels. That's why it gets the value of 1 here. If I click onto the road, you're gonna get 0 because the super object is not classified as a parcel. And yep, that's a way how to find a potential threshold and a feature to classify image objects. For this approach, actually, the second way to investigate the feature range would be better using the feature view. So the image object information window displays multiple features for one single object. If you use the feature view, this displays one feature across all image objects on image object level. And you actually could select here the blue, double click that feature, and then it's going to colorize the objects based on the feature value. And I need to check the fill. I unchecked it actually, and the opacity, and now maybe also turn off the outline. And now you see by default it's colorized in a grayscale. So white means very high value in that feature, in this case it's blue, and dark means low value. And that actually has a nice contrast of impervious and non-impervious surface. You can do it for all, now double click blue, also for green it looks different. Now you also could use a combination and so on. Brightness maybe, so you are free to find a threshold. And additionally, what is very helpful is here, if you check the checkbox at the bottom, so I double click blue now, so we see the blue feature, check this checkbox and then right click on the blue and choose update range. And that will update the range down here. So it fills in some value for the min and max, and that means, so what it does, it colorizes the objects in a different color scale from blue to green. Blue means low values and green high values, and it only colorizes objects that fall within the range here, so 50 to 247. And if the objects fall outside of that range, they're gonna fall back to the grayscale color. So let's increase maybe the bottom to 100. And yeah, you see those grayscale colorized objects now are outside of the defined range here. So this also helps to find a threshold, and that's actually what I used here. So in our case, we went for 75. So I'm going to enter 0 here as low value and 75 as max value. And no, the other way around. We used greater than. So let's go for 300. I think we have 8-bit data. So yep. And now you see all the objects that are colorized are, or in this blue color, are within that range, and all the others are lower. And that, yeah, actually depicts all the impervious areas. And that was my approach, right? It's not perfect, but yeah, you can use the image object information window or the feature view to display features and find a potential threshold. Let's go back to class color and display the outline. Okay, and now that we have this, the next step would be to transfer this information that we have now for each parcel to compute somehow the percentage of impervious surface of the sublevel compared to the whole outline of a single parcel. Okay, and let's have a look at this, and then we actually have our results. So I'm going to display the parcel level, which is still showing those blue objects, which are our parcels. We want to classify actually into 4 different classes. Let me check. Yes, so we're gonna have 4 classes, 0 to 25% coverage of impervious per parcel, 25 to 50%, 50 to 75, and 75 to 100. So we're first gonna create those classes, and I'm gonna call them Impervious 0 to 25. That's the first class. Gonna give that a green color because that is green indicates good, right? So and I simply can duplicate those classes, and I'm simply gonna change impervious this to 25 to 50, and now it's getting more yellowish, and again impervious 50 to 75, and that is already orange. Okay, and last but not least, the class is impervious 75 to 100, and I think we just have one object or something, one parcel that fulfills this criteria. Okay, and actually we could use a sign class as we did before, but I'm going to show you a different approach where you have to use the algorithm classification. And what classification does, it actually looks at the class definition within the class. So what we're going to do is we define what impervious 0 to 25 is in the class hierarchy, in the class itself, instead of using a sign class and defining it in the domain. So what we can do is actually you can open the class, and if you double click on this and min, you can define expressions. So you can define conditions, and we are simply going to use in this case a no, we're not using a threshold. Let's have a look. So if you go under object features, we first need to use find that feature, and it's under the same topic as before, the relations to objects that we use for super objects, right? We also have this for sub objects. And here you have the relative area of, and we're gonna create this relative area of impervious distance 1. So it's gonna look one level down because we have here sub objects, and it's gonna compute the relative area of impervious. Okay, and let's use this one, insert, and now we can actually define a membership function, and this helps actually to define fuzzy membership relations, but actually I'm going to use fixed thresholds or fixed membership functions. So you can choose from different predefined curves. You also can modify them as you like, but I'm going to go for this one, which means only those that are included in this range, which is between 0 and actually 0.25. So everything that has a percentage of 0 to 25% are my impervious 0 to 25. And yeah, you also can have a look at the feature view. If you double click the impervious, again, you're gonna get the grayscale. I'm gonna increase the opacity, and there you see we do have different colored parcels, and those represent the relative area of impervious of the sublevel. And now I have to go into each class and define this membership function. So yeah, relations to objects, sub-objects, relative area of, and I'm going to use this one, and in this case I'm going to set it to 0.25 and 0.5, so you can go ahead and do it yourself. Okay, so I've defined that for all the impervious percentage classes here, and I'm going to switch back to class color. Okay, and now we need to classify the objects based on the definition here in the classes, and for that we're going to use the algorithm classification. And we're going to create a structural process, going to call it categorize parcels. And I'm going to insert a child, and here we're going to look for the classification algorithm, this one. And now we have to make sure that we are working on the right level. It's a parcel level, so a super level. Class filter, I only want to reclassify parcels. Makes sense. And now the active classes, you have to select the classes that you want to classify into. So those are the classes that I have defined the membership function within the class itself. And this algorithm looks into the definition of the class and uses that for classification. Let's simply run it, and here we go. Okay, I see a few blue parcels. Let me check. Okay, they have a relative area of 0. That means that I probably have to simply change the bottom to, yeah, I'm gonna simply change to -1, it doesn't matter. And rerun this one, and they should be put into the green class. And you see parcels now are categorized based on the percentage of impervious surface of the sub-level, our analysis level. And now what pops out here are the red ones. I think red and orange are a bit too close together. I'm gonna choose a dark red for this one. Because yeah, I think that's the only one here where we have more than 75%. Let's click on that one and see. Yeah, it has 88%. And yeah, the green ones have a low percentage, 0.04. Yeah, so that shows you how you can utilize those hierarchies within eCognition for your analysis workflow, right? And this example nicely shows how you can use different levels and the hierarchy in eCognition and how to connect it to create information of your, in this case, of our parcels, right? Last but not least, export our results. And yeah, we want to export statistics. So I'm gonna add a new structural process here, export statistics. So instead of exporting the shapefile and stuff like that, I'm interested in the statistics. So what we actually can do is also export the average percentage of the parcels, of the impervious surface per parcel, and we can compute the overall area of impervious surface that we have for the whole, for all of the parcels, and so on. So let's first compute a bit of statistics, and then we're going to use that for export. So what I'm going to do first is I'm going to use compute statistical value. That's an algorithm. And yeah, what I want to export is, what I'm interested in is the average, so the mean of this percentage of the impervious surface. So I need to define in the domain for which objects I want to calculate statistical value, and it's going to be objects on the parcel level and the class. Those are the 4 classes that I'm interested in. And variable here is the output, and I'm going to call that one mean imp. And the operation, all right, it's going to ask me what kind of variable this is. It's going to be a double and a scene value, so one global value. And operation is mean. That's gonna give me the mean of the feature that I select here, and that's gonna be the mean of this, where are we, relations to objects, sub-objects, relative area of Impervious. Yep, so that's gonna give me the mean percentage value. Hit OK. Oh, I'm actually gonna execute it, drop it in here. And you see here the variable pops up in the image object information window, so 22, so 22.8%. What else is interesting? Yeah, maybe the overall area of impervious surface. I'm simply gonna copy and paste this one. So do we have, yeah, the sum, and we're gonna call this one overall area imp, and that's also going to be a double. And now we are interested in the area. Where are we? Geometry, extend area. And if you right click here, you can change the unit, and I'm going to change the unit to, I mean, in my case, square meters makes sense to me, and I'm going to use the area. And now it's important because we have the impervious class at the analysis level, and yep, so we only want to have it for the impervious class. Execute this one. I'm going to change the unit here as well, might be important. Okay, execute this one. And there we have the square meters, 13. Oh, that's quite a bit. Maybe let's change the area. Edit unit square. Okay, 0.13 square kilometers. Okay, and you could compute any statistics that you like for export. Let's have a look and go to our export algorithms. Yeah, let's go for export object statistics for report. Because if you're using export project statistics, only global values will be exported. But I'm also interested in the single values for the single objects. So I'm going to choose this one. We are looking at the parcel level, class filter, our impervious. That looks good. If you leave the default settings here for the export path, it's going to create a results folder in the workspace directory. So that's going to be fine. Not going to change anything here. And you can choose the features here. And I'm going to go for the variables that I have created, which you're going to find under variables and array features, variables, and scene variables. And that's going to be the same for all image objects, right? And then I want to additionally have exported the, for each parcel, the relative area of impervious. That's it, okay. It's going to create a CSV file. Let's execute this one. And now you can open actually the folder where you have stored the workspace. In my case, it's in the data directory. Right, my workspace was called Parcels Analysis Workspace. And you see we have a results folder and object report statistics, and here's a CSV file. And yeah, here you have the result of the statistics that we've exported. We have the level exported, so parcel level, the name, and this number here is the percentage of this specific entry, so this parcel itself. You also could have exported an ID if you have an ID for the parcels or whatever. And then we have the mean, which is the same, the mean value here, which is the same for all entries in our table because it's a global value, and also the overall. Right, and this value, this is going to change. That also makes sense. So that is specific to each parcel is the value of the impervious surface of the sublevel. Okay, let's keep it at that. So that was the whole rule set from starting from identifying parcels, loading the data first of all, right? And then we identified the parcels and classified those that have the attribute in the attribute table mobile homes or single family in this column LU_GRP. After we've created image objects based on this vector layer and classified the parcels that we're interested in, we created a sublevel using the multi-resolution segmentation. And then we classified the parcels based on a simple threshold classification. So we used the mean blue and a threshold of 75. So everything that's greater or equal to 75 in the mean blue. All objects are classified as impervious. It's not perfect, you can improve it. That's up to you. And then in the next step, we categorize the parcels on the super level based on the relation to the sub level using this relative area of two sub objects. Then we computed global statistics, in our case, the mean impervious surface per parcel and the overall area, which was classified as impervious. And then we exported it as a CSV file. Wouldn't make that much sense for me, to be honest, but you also could update actually or write the information into the input vector layer, or you could export your results as shapefile. So everything is possible. So you get your data out of eCognition as you like. Good. So that was it. Try to think of examples where you can use hierarchies for classification, how that approach could help you to classify something that you didn't think of maybe. It really helps and really makes sense if you have a hierarchical structure of your classification, of your hierarchy, class hierarchy. And yeah, now you know the basics, how to use it and where to find those relational features and those links of image object levels. And yeah, be creative and try it yourself. Before I forget it, actually in the data folder, we do have more tiles, right? So you could actually save the rule set here, right click, save rule set, create another project based on another tile, and run the whole rule set and see if it works there as well. It should work exactly the same. And if you watch the other videos on YouTube or have a look at those from the ground up materials that we actually have one on customized import, which makes sense here because you can create a customized import which creates automatically projects for each tile in the data folder, so you don't have to do it manually. It's then one click. So have a look at the customized import material that we have, and then also have a look at the server processing, so how you can do a batch processing in eCognition. And in combination with the datasets that you still have for this exercise, tiles, you can actually practice it. So create a customized import which creates projects automatically based on each tile, and then run this rule set using eCognition server, which allows batch and parallel processing. That would be an exercise for you or some homework. All right, so that's it for me. I'm gonna stop now. Have a great day and goodbye.